Okay, let's get started. Before anything, do we have any question up to this point of time? Okay, so we know that in R, there are a lot of, almost all of the mathematical distribution that we know so far already built in R. Okay? Or I should say that all of the PDF and CDF, all of these mathematical forms are already built in R. But in order to use them, we have a set of functions to help us do the operation upon distributions. Okay? So actually there are a set of 4 common functions that generally apply to sorry. I forget to whoa. What the? Okay. Okay, so actually there are 4 common operations that generally apply to every distribution. Okay, there's a D function for probability density function, and there's a P function for CDF. Okay, there's a D function that given X, it will return the density of X. Okay, and then CDF is that if you give it a value, actually also give an X, then you will show the value of CDF. It's kind of like this, right? This is PDF, right? So you give an X1, it will actually return the density of X1, okay? But if you give the X1 to the CDF, it will actually return the probability that from negative infinite, from the left tail up to X, okay? So actually density X by itself do not have too much usage, right? But actually CDF actually represent the probability from the left tail up to X, okay? So these are the D function, the P function, and actually the Q function is the reverse CDF. Sometimes you want to know sometimes given X, you want to know the probability, right? And that is CDF. And sometimes you know the probability, you want to know X, okay? To calculate probability from X, you are calling CDF, okay? So you are using the P function, right? Okay. And if you know the probability and you want to know the X, the corresponding X, right? See, if I want to know for example, the 95% confidence interval, right? For example, I want to know that I want to make sure that with the 80% probability that X would be lower than certain value, right? You know the probability, but you do not know the X, right? So you will use the Q function. You use the Q function, send in X, send in the probability, and it will return the critical value, which X, Okay. And then the last function is the R function, and that is for random draw. Okay. You want to draw n point from a certain distribution. I should see this. It's for random sampling. Okay. Given the distribution and its argument. Okay. So the distribution could be any one of these. Okay. For example, normal, then you have normal. Poisson, you have Poisson. T distribution, you simply have dt, and this is uniform distribution, right? Binomial distribution, chi-square distribution, geometry distribution, hypergeometry distribution. See that, right? Okay. So you replace this with the name of the distribution, okay? And you would replace this with the argument of that distribution. We know that all of this theoretical mathematical distribution has argument, right? For example, normal distribution, you need to specify its average and its standard deviation, right? For binomial, you need to specify the number of trial, right? And also the successful probability, right? So for every one of this mathematical theoretical theoretical mathematical distribution, there is a name, right? Binomial is the name, right? And they are argument. For example, for binomial, they are the number of trial and the probability of success, right? For normal distribution, you have the average and you have the standard deviation, right? So in R, we have this 4 common distribution operation, D, P, Q, R, respectively stand for density, probability, quantile, and also random draw. Okay? The reason that we call it quantile is because that we are talking about for example, if I'm talking about 80, 0.8, right? I mean that I want to get the value of x that below that x has an 80% of probability, right? So that's called quantile, right? You specify the probability and you want to know the x. Yeah, you want to know the value of x. So it's a reverse function of CDF. Okay, that could be a little confusing for those who are not very good in probability. Okay, so let's do some real example to make use of this probability function. Okay. So first thing, we want to practice the D function, which is the probability density function. Okay. Now let's see. The D function. Now this example, I'm using normal distribution. Okay. Because I'm using normal distribution, so this is norm, right? Okay. And normal distribution actually, if we go to RStudio, let me go here. Let me run to, yeah, let me run to this part. Okay, see, D normal, we can press F1 to see its online help. As you can see that for normal distribution, there are four functions, right? And within each function, they are actually arguments, right? This is the average, and this is the standard deviation, okay? So it actually has a default value, 0 and 1, right? You know that there's a specific kinds of normal distribution called standard normal distribution, right? standard normal distribution is the normal distribution with average 0 and standard deviation 1, right? Standard normal. So actually, if you do not give this argument, then we are talking about standard normal, right? Okay. So this is standard normal because I do not give mean and standard deviation, right? And what is x? Now the x is actually could be a vector, okay? So right now I'm drawing a curve, right? I want to draw the density function from -4 to 4, okay? So if I run this, what happened here? Okay. When I do this, I actually draw the normal distribution from standard normal distribution from -4 to 4, okay? And this is just to specify the label attached on the figure, right? Okay. So this d-norm function actually give us the density for each of x, okay? But this is for normal distribution. Let's try another distribution, which is binomial. Binomial is actually a discrete distribution, right? So you cannot draw curve on this binomial because for binomial distribution, it only apply to integer, right? So you need to give it, for example, I'm doing binomial, and this time, as you can see that for binomial, they are the number of trial and they are the probability of success. Okay, so they are two arguments. Okay, so this time I'm telling it that I'm going to use x value 1 to 10. Okay, and the number of trial is 10, and the probability of success is 0.5. Okay, so if I draw this, this is what I see. Okay? So density function, they act differently for continuous and discrete distribution. For discrete distribution, it basically returns the probability. This is not density. Okay? See, for discrete value, it do not have the ideas of density, right? It is the probability that it happened 2 times, it happened 3 times, it happened 4 times. Okay? It is not the ideas of that you need to integration. Okay? So this d function is actually act differently for discrete and continuous variable. For continuous variable, it actually returns the density of specific x. Okay? For discrete distribution, it returns the probability directly. Okay, so usually you can the d function is a little bit complicated, right? So you need to use it in continuous. Usually in continuous function, it is not very useful because the density by itself do not represent probability, right? See. So for continuous distribution, the d function is usually it was just used to draw the PDF for your understanding, right? It's very difficult to calculate probability directly from the d function for continuous distribution. Okay. But for discrete distribution, you actually can acquire the probability directly from the d function. You get me? Problem? So they use it differently. They're just a little bit complicated. Okay. So here I, in addition to get the value, I actually make a plot for you, right? So I just want, in this code chunk, I draw them side by side, okay? So you can compare the difference, different way that when we use the continuous distribution D function and discrete distribution D function, okay? So they are different, okay? So as you can see that in this D function, the x can be a vector, okay? So you can acquire a series of numbers. If we give it a vector, if we return a vector of probability of density, okay? So there are some discussion, right? And this is actually your homework today, right? So see, let me try to answer some of this for you, right? Some of this is kind of blurred. For example, the mathematical form, I'm not telling, I don't mean for you to write down the mathematical form, right? Okay. So I just want you to describe that for continuous distribution, it is actually a continuous function, right? By continuous, I mean that for every x in the real number, there is a corresponding density, right? That mathematically it's a continuous function along the real number, right? But however, for discrete, it actually only applies for some discrete values, okay? For count, it's start from 0, and it could be up to n, right? If you try it n times, the largest number is n, right? So for discrete, it's actually, that's why we call it continuous and discrete, right? For continuous, we are talking about a continuous mathematical function. For discrete, we are talking about a function that only has value on each discrete alternative values. Okay. As you can see that the plotting code are different, right? When you want to draw a continuous function, you use curve because it's a continuous curve, right? When you want to draw a probability, discrete probability, you cannot draw curve anymore, right? You need to use bar plot, okay? And then the label on the x-axis, they are also different, right? Here, they are probability, okay? This is the probability of happen 2 times, happen 3 times, happen 4 times, okay? But for continuous, it's not probability at all, okay? It's the density, okay? So density are different from probability, right? I want you to like take the note and write the answer here, okay? Now there are some exercise, okay, for you, and again we still have some time, so I can like lead you through this exercise. But you need to do this by yourself, okay, when you go home. So the first thing is acquire the probability density of standard normal, right? So from -3 to 3, okay? So because we are going to know density, right? So we are calling D norm, right? Isn't it? Okay. And because we are talking about standard normal, right? So we know we don't need to put in the argument, right? Because standard normal the default is already standard normal, right? So we don't need to put in this one, right? So so what we want to do, we just put, see, this actually represents a vector, right? So if I give this vector to D norm, it actually returns the density of standard normal. It actually returns the value of PDF of standard normal when x equal to -3, -2, -1, that type of thing. Okay? So this is the way to use the D function to calculate the... But this is not probability, right? Okay? This is not probability. So actually, it's not very useful, right? It tells you the density, but actually, it's not probability. Okay? So now let's do another exercise. This time, I want you to plot the probability density. So normal distribution 120, which means that the mean is 100, standard deviation is 20. Okay, at this thing. Okay. See, I want to know the density of this distribution. Okay, at this point. So first of all, we get the value, right? How to do that? Right? And this is the x that we want, right? Is that? And we need to specify the mean as well as the standard deviation, right? It's no longer standard deviation, standard normal, right? So how much is the mean?
It's normal distribution, so the mean is 100?
Yeah, 100. And standard deviation is 20, right? Okay. So these are the density, right? But it's not very useful, right? So what do you want to do with it? Okay, but actually you can plot them, right? So you can and I told you to use this argument in the plot. Okay. This is just to specify the plot type, and sorry. Okay, I should do that. It's missing. Well, what's the problem?
Professor, the pink, the word pink, it doesn't.
Yeah, I saw. What is the problem? Now we have okay. So there's some typo. So it actually this is the density, okay. But actually, normal distribution is not a discrete distribution. So you plot this, it's actually kind of misleading, right? Okay. So I want you to label this chart, right? In the main and actually x and y lab, right? So so you can say main equal to what is the PDF of right? This is the if you want to choose a title, you want to put a title here, right? Okay. Then what is the X label? It's simply X, right? And then what should I put in the Y label?
Density.
Any more answer? Yeah, density is the correct answer, right? Density is the correct answer. Because now here should be density, right? So, okay. So this is the PDF of normal distribution, 120. And sometimes we'll say that mu equal to SD equal to, right? Let's make it clear. See, but there are problems. You see that the X label is kind of wrong. See that? Okay. So, but for now, let's if you really want to change this label, you actually need to change the X also, right? So I think the best way is to like okay, and then that would be easy. That would be better, right? Because of this plot function, if you only give it X, it will assume that if you only give it one value, it will actually assume that X is 1, 2, 3, 4, 5, 6, 7, right? So if you want to specify X, you need to do it this way, right? Then the X and the Y, right? And this is the plot type. If you do not use plot type, you simply show this. Okay? So, well, maybe this is better than than drawing a edge, right? So actually, this is better, right? Because they are density. It's not probability. And drawing this kind of like give you a wrong impression that it is the probability, right? Maybe maybe this sorry. Maybe this is even better, right? Okay. So for continuous distribution, this D function is not very useful unless you want to do a plot. Okay. Okay, so let's do some discrete probability. Okay, this is binomial, right? So this means that we repeat 10 times, and the probability of success is 1/6. Okay, so how to do that? We want to acquire the probability, right? So the binomial, right? And these are the X that we want, right? And right? These are the argument of binomial, okay? And okay, what's the problem? Oh, yes. Okay, so you see the probability of binomial 10, 1, 6 at 0, 2, 4, 6, 8, 10. Okay. Now, if we roll a fair dice 10 times, what is the probability to have exactly 2 ones? A dice has 6 sides, right? 1 is 1/6. The probability of that appear 1 is 1/6, and you sort it 10 times, right? And you want to have the probability of having exactly 2 ones. You actually can look at this, right? Which probability? You sort of fair dice, right? Fair dice like 10 times. And what is the probability that you exactly have 2 ones? You actually have the answer here. Anyone?
Is it the last one? The one on the place of 10? Because you rolled it 10 times?
No. What does it mean by 0? It means that when you throw 10 times and you see 0 ones. Okay. You got it?
So it's 0.2907.
See? So if I want to answer this question, the code is like this, right? See? Right? Because I want to, this thing should follow a binomial distribution 10 and 1/6, right? Binomial distribution 10 and 1/6. And I want to know the probability that it occurred only 2 times. Okay? See, this is the definition of binomial. Okay, the distribution of the number of success while repeating experience of success rate p for n times. Okay, so I repeat 10 times, right? And the probability of success, which is the probability that it appear once, is 1/6, right? So I want to see the numbers of success, 2, right? Okay, so that's why I put 2 here. So what is the probability of it would like occur like 0 times?
0.16.
Yeah, it's this one, right? Okay. What is the probability that it occurred 10 times?
0.0.
It's this one, right? So if I want to, this is from 0 to 10, right? What is the probability that it will occur like 11 times?
Not possible.
So the probability of not possible is 0. Yeah, it's 0. Isn't it? You can try it if you want. See? You see it, right? Okay. So roll fair dice 20 times. What is the probability of having less than 5 ones? Can you try to do this by yourself?
Probability of 0 plus 1 plus 2 plus 3 plus 4.
Sorry?
Less than 5 meaning it's the probability of 0 plus probability of 1 plus 2 plus 3 plus 4.
Yeah, correct. But how can we do it in R? Try to write a code. First of all, we need the binomial for sure, right? Isn't it? Right? And you want to know it's 0 to
And then add all the answers.
4, right? And then I repeat 20 times. and the success rate is 1/6, right? So is this the answer?
Add all of them.
Yeah, you need to add them, right? You need to add them. Something. Okay? Right? You see it? Okay? Okay, and actually there's a better way to do this. Okay? Which is, if I call the P function, I can actually simply do this, right? Because the P function is actually the probability from the left tail up to 4, right? From left tail up to 4. Isn't it? Okay. So this should give the same answer, right? I mean, this two should give the same answer. See? Okay? All right. So this is to like give you some exercise about how to use this P function. Okay, and let me emphasize it again, right? This P function is a little bit tricky, right? For discrete distribution, it actually returns the probability directly. Okay. For continuous function, it returns the density, right? So it's kind of difficult to see the probability directly from density, right? So you need to use a P function a lot when you try to estimate probability in continuous distributions. Okay, now let's go to this cumulative density function, right? Okay, so I told you that the difference is that when you use P, it actually returns the probability from the left tail up to X, okay? Actually, it can also be a vector, right? It can also be a vector. We are here, okay? So I want you to, the probability of X within this period in standard normal, right? So if I want to know the probability that X will fall within this interval in standard normal distribution, right? What should I do?
Probability of 2 minus probability of -1.
Can you get slower? I think that's the other.
So probability of 2 will give you the
No.
probability.
I mean that don't answer it
Oh, sorry.
yet. Okay, that's the other. Like that our classmates have some. Okay, so how can we do that? We think about this, right? Because I want to know the probability that in an interval x1 to x2, right? So, but I already know the CDF of x1 and x2, right? See, so I basically have to like do a difference, right? See the difference between the two. Okay. So how should I do it? Here. Now, first of all, right? See, actually writing code is right. Don't try to think it over before you write in code. Write whatever you know, right? You know that you are doing normal, right? You know that you are doing standard normal, right? And you know that you are going to know the probability, isn't it? That's what you want to do, okay? But first thing is you want to know the CDF up to 2, right? Isn't it? Okay. So, oh, sorry. So this is 2, isn't it? Okay. Because they are standard normal, so you no longer need to put the mean as standard deviation, right? It's already default. And then what? Anyone? Louder, louder.
Minus P norm minus 1.
P norm minus 1, isn't it? Right? So this is the probability, right?
So, Professor, for the function P norm, if we do not mention the mean and the standard deviation, it wouldn't be like the value of this normal distribution.
Yes, yes, because this function has a default value here, right? And this is standard. This is the argument of the standard normal. Okay? See that? Okay. Okay. And then more exercise, right? I want to know the standard deviation from the left tail to -3. How much is that? Try to do it and raise your hand, okay? Can you do that? It's still standard normal, so you're still doing this, right? But right now I'm talking about from the minus infinite, which is the left tail. Okay. So it's easy, right? This should be a very easy one.
Minus 0, just P norm minus.
Yeah, P norm -3, right? This is the answer. Okay? See? Okay. Now, so actually, as you can see that standard normal, if you have a standard normal distribution, actually within 3 standard deviation, it already has a 99.73% of probability, right? This is 3 standard deviation, okay? So most of the, sorry.
Sorry, can you please show the answer to the previous one?
This one?
Minus infinity.
Oh, sorry, I put it wrong here. It should be here, right? And this is not right. Okay. So for this one, I'm talking about normal with mean, with average 100 and standard deviation 50. I want to know the interval here, right? So I'll give you to do that for your homework, okay? And then for this one. So if the distribution of temperature in this season follow normal distribution, right? You get this information from some weather bureau or something like that, right? So what is the probability that tomorrow's average temperature is higher than 30 degrees? You do that? You know the temperature distribution, okay? And you want to know the probability that the temperature is higher than 30. Okay? So how to do that? Yeah?
1 minus probability of 30 results.
Right. Because right now you're going to calculate the right tail probability, right? But the P function only give you P left tail probability, right? So you need to use 1 minus the left tail to get the right tail. Got it? Okay. Now flip the coin 100 times. What is the probability to have less than 35 heads?
Same.
Sorry? No, it's not the same.
No,
Yeah. A fair coin, okay? 100 times. So we are talking about binomial. And now this is a little bit tricky, right? X. And then repeat 100 times and probability 0.5 because it's a fair coin, right? So what is this X? Wait a second. Anyone else? Less than 35 heads. If it happened like 20 times, it fit, right?
Yeah.
30 times, it fit, right?
Shouldn't it be P volume instead of D volume?
Sorry?
Shouldn't it
Good.
be volume?
Good. Should be P,
P.
right? It should be P, right? And what is the X?
35.
Is that right? Less than 35. Not including 35. Right? Less than 35, right? So if you're using the P value, the P function, it count to X including X. Okay? So what should be the X? Yeah?
Probability of 0 to 34. So probability 0 plus 1 plus 2 plus 2.
Yeah, you can plus everything from 0 to 34. Or you can use just the P function and use 34.
34.
Right? This should be the same. Zero to 34, right? And you use the D function, and you need to add them up, right? It should be the same. Okay. So the probability is not high at all, right? If the coin is fair, its probability is actually quite low. Okay. Now, actually, this is exactly the here, right? Here's the PDF. It's exactly the same. Should be exactly the same. Now this one is a little tricky, right? We are talking about the probability to have no greater than 20 and no less than 10. Okay?
Between 10 and 20.
Yeah, including
Including
10
10 and 20.
and 20. Okay? So, if we want to do it with D value, okay, it's actually 10 to 20, right? It's actually easier,
Yeah.
right? if it was discrete, right? It is actually easier if you, it's more straightforward, right? See? Otherwise, you have to do, if you want to use P function, then you,
Then P of 20 minus P of 20.
yeah. you need to call the p function twice, right? This thing has to be 20, right? You need to be careful. Is this right?
Yes.
No, this is incorrect. Yeah, it should be 9, right? Right? So you need to be careful about the boundary condition, right? Including 10 and 20, right? So if you use 10 here, you will exclude 10. Isn't it? Right? Yeah, it's 2 are the same, right? If you use 10, then you get it wrong.
But it's the same answer for both 10 and 9.
Sorry?
We got the same answer for 10 and we got the same answer for 9. When you changed it, the answer still remained the same.
Yeah, but should be this way because they are actually, they should be different. Yeah. Okay. Just.
Shouldn't it be? It's not a coin anymore. It's now a dice. Isn't there not 1/6 instead of?
Oh, sorry. Yeah, I get it wrong. It should be 1/6. Because we are not throwing coins, we are actually throwing dice. Okay. See? See, they are different, right? So they are. You should be 9. Okay. Oh, sorry, we missed the break time already. So let's take a quick break. We'll be back in 15 after 11. Okay.
这个 file 晚点会上传吗？
这个已经给你们了，不是吗？
对，那老师现在打这个，因为我怕来不及打完。
OK。
哈哈，1小时。
可是我如果上传了，那你们这个就是给你们写作业的啊。
哦，对啊，我想说老师已经先打了。
我上传了，那你们就不用写作业了，不是吗？
老师今天应该不会交完吧？
会，我今天会。
哦。
底下的东西其实我就稍微秀一下给你们看就可以，主要是这2个方向。啊？你说？你说什么？
可是我可以看这个看看是有做到，因为我好像按错了东西，把这一行删掉了。
什么删掉？
就是这一行的这个，可是这个是要我们自己做的，因为我不知道这是不是不小心按到Ctrl C，我就回去。
你说？哦，对不起。